Negative sulfurs are weaker bases, then what do we suspect about negative sulfurs as leaving groups?
Not as bad.
Not as bad. They should be better leaving groups. Okay? Okay, now, let's talk about another structure with sulfur versus oxygen. Where do I want to put the charge on this? And I'll put a negative there. Okay. What about resonance, stabilization, and interaction? That's true. Yeah. Which one has better resonance?
Wouldn't it be shared more equally with the two oxygens?
Right. Right. Remember this one, right, has, so this can go there, and that can go there, and then the negative charge ends up there. But this one, doesn't that look the same?
Okay, but it's not the same.
The sulfur can hold the negative better.
Well, one, sulfur can hold the negative better. But what else? What's the other big difference? What have I not? What's the biggest difference between sulfur and oxygen?
Size.
Size. Sulfur is bigger, which puts those p orbitals in a different place than the p orbitals on carbon. And so sulfur can't overlap with carbon in the same way, and so it can't resonate in the same way. So resonance is better with two oxygens. Okay? So, if we look at just a plain old ester, so if we just look at a methyl acetate. Yep. I'm over already? I told you guys had to watch me. Let me do this really quickly. If we look at methyl acetate, it will actually resonate, and there is a resonance form where there's a charge stabilization or a charge separation. There's a zwitterionic resonance form. But again, like most things, resonance stabilizes. So even though there's a lot of electronegativity around this carbon, and even though this resonance structure has charged groups, resonance tends to stabilize esters more than we would expect given the amount of electronegativity around that carbon. Right? Thioesters can't do that. So thioesters, we've got a sulfur which ends up being a better leaving group that is not stabilized by that ester resonance. And so that both makes this less stable and the leaving group more stable. And so that combination makes thioesters high energy molecules. We'll start right there on Monday.
Yeah.
We will start right there on Monday, but think about that statement.
So they are,
They are high energy molecules.
and they're better leaving groups?
Yeah, the sulfur is a better
sulfur is
leaving group
weaker than the
because it's a weaker base than the oxygen. And the ester itself is not stabilized by resonance,
which makes it higher.
which makes the starting material higher energy.